Starting off today's lesson, we're just continuing with example 5 in our notes. Tonight you'll do day 2 of 3.2, independent events and conditional probability. We are going to actually assign events to A and B or E and F so that we're not dealing in just hypotheticals. So on example 5 it says a company has 8 smartphones for the sales staff to use for the sales calls. 5 are iPhones and 3 are Androids. 3 of the iPhones are new and the 2 are older. 2 of the Androids are new and 1 is older. A sales representative selects a smartphone at random and notes that it is a new model. What is the probability that it's an iPhone? So we want to know the probability that it's an iPhone. Remember, the question is always the first thing. And he already noted that it's new. So our given probability, or our conditional probability, is going to be the probability that we have an iPhone and it's new, divided by the fact that it's new. Alright, so we have our formula. The trick is to get the numbers in the right place and what numbers to use. And I'm going to introduce, we've talked about using just equations, Venn diagrams. Something we haven't talked about in a while are trees. So if you think first about what kind of phones we have, we can either have an iPhone or an Android phone. And it said that there were 5 iPhones, 3 Android phones. And then between your iPhones, you've got new and old, and Android, you've got new and old. But remember, when you talk about new iPhones, remember there's only 5 iPhones. And it said that for the new ones, there were 3, and there were 2 old. For Androids, there were 3, 2 new, 1 old. Alright, so what we need to know is, since it was new, so the probability of a new iPhone in terms of the entire problem was there were 3 new iPhones out of the 8 total phones in the drawer. And for the new Android, there were 2 out of the 8. So where do these numbers fit into our equation? The top part says it has to be an iPhone and it has to be new. So we got that number to be 3/8. And then we're going to divide that by, now hold on just a second. Now if you were wondering if we were going to multiply these together, remember this is Android, so that's not even up here. Okay, it's new and iPhone. Those are the 2 we need to focus on together, not the fact that we have 2 separate numbers for new. Now, however, if you get to the bottom and when it just says new, that's where we say, okay, well there's 3 new ones that are iPhones, and there's 2 new ones that are Androids. So this becomes 3/8 divided by 5/8. Now, why do you multiply versus add versus multiply there? In the denominator, if you're talking about all of them, we're talking about the new Androids and the new iPhones. So if you do those together, that's just adding, or. And then I divide this out, 3/8 divided by 5/8. Keep change, flip. And our answer becomes just 3/5. For example 6, we've kind of already talked about this type of a problem. If you would like to glance at the solution, feel free, but we're going to go ahead and move on to example 7. Example 7 says the school paper took a survey and found that during the winter vacation that, and then I've gone ahead and listed most of the information that's in this problem to the side here in terms of probability and what those answers would be as decimals. Then at the end it asks, a random student is interviewed and it is found that the student plans to visit family over winter break. Okay, so that's a satisfied conditional. They are visiting family. What is the probability that she plans to use air transportation? Remember, the question is always the first part. Given family. So this would be the probability of air and family divided by family. Family and error was listed at 18%. Don't need to multiply, not about independence. It's just given to us right here. And then the probability of family is 30%. And when you divide here, we get 0.6. And our last problem for today, suppose a jar contains red marbles marked 1, 2, 3, blue marbles marked 4, and white marbles marked 5, 6, 7, 8. So let's go ahead and mark how many of each one there is. So of red, there are 1, 2, 3. Of blue, it says there is one marked 4, so there's one blue. And then of white, which I'll use black to note, there is 5, 6, 7, 8, so there are 4 white marbles. A marble is selected at random and its color and number are noted. Part A asks, what is the probability that it is red? Okay, there are no prerequisites or anything, so this is a simple probability problem, 3 out of 8. Okay, part B. If the marble is known to have an even number, what is the probability that it is red? Okay, this is conditional because we can only pick out of our red marbles even numbers. So 2 is the only one we can figure out there. So the question is asking what the probability that it's red, given that we have an even value. Well, the probability and even would be 1 out of the 8. So remember this numerator, maybe we should start over. The top part should always be the overlap of red and even. So that's 1/8. And then the probability that it's even would be out of 4/8. And if you want to work this out or use your calculator, you get 1/4. Part C, if event F is a red marble, is drawn and event B is an even marble is drawn, are the two events independent? Meaning, does one have anything to do with the other or not? So independent would mean that they have nothing to do with one another. And if we say that they are independent, we have a formula to prove that. E and F equal E times F. All right. Well, what is the probability that, just think generically, that we draw a red marble and it's even? Well, red and even is what we figured out right up here, and it was 1/8. Probability of E on its own, let's see, E was that, oh, I'm sorry, I meant to put B here. Now they're mixing their A's and B's and E's and F's, I can't keep up. So B on its own is that there's an even marble. Okay, well that's 4 out of the 8. And then F is that it's a red marble, which is 3 out of the 8. Now, is this true? If so, these are independent, and if not, they are not. And we get 12 out of 64. However, if you reduce fractions, maybe they're equal. So right now we don't know. And if I reduce this down, I'm going to get 3/16, and they are not. So the answer is no, these are not independent. And of course they have nothing to do with each other would be preposterous because a red and even value is on the same ball. It obviously has something to do with each other because they are written or colored on the same ball. Go ahead and do 3.2, day 2, and if you have any questions, let me know.